Here are the video solutions for NCFE Level 2 Functional Skills Maths. This is section B, which is the calculator part, and this is from December 2019. So let's take a look at question number 2. So the first thing we need to do is work out the area that we have here. So what we've got is a rectangle, and here we have a quarter of a circle. So the rectangle, that should be nice and easy. That's simply 3.3 multiplied by 9.25, and that is 30.525 square meters. Now I believe in the question we've been told to use pi as 3.14. Sorry, I should be doing the workings out down here, but I don't want to be scrolling up and down the whole time. So the formula for the area of a circle is pi r squared, but this is a quarter of that, so we need to divide by 4. So that's going to be 3.14 multiplied by 3.5 times 3.5 divided by 4, and that comes to 9.61625 square meters. So the total area is going to be 30.525 plus 9.61625, and that comes to 40.14125 square meters. Okay, now we know that it's the charge is £4.25 per square metre. So what we need to do now is simply multiply £4.25 by 40.14125 square metres, and we get a total cost of £170.6003125. Of course, pounds and pence we should be rounding to 2 decimal places. So the third decimal place is a 0, so that will simply round down to £170.60. Okay, part B. So what we have here is, it's often very confusing with VAT. We had a price and then we added 20% of that amount on top of it. So we had the full amount, 100%, plus VAT at 20%. So what we need to bear in mind is that £250 is 120%. So 120% is £250. So what is the 100% when 120% is 250? Well, what I'm going to do here is I'm going to work out what both of these are multiples of 10%. So 10% is 12 times less than 120, so I need to divide this by 12 as well, and £250 divided by 12 is £20, or 20.83 recurring. And so if 10% is this amount, then what is 100%? Well, that is 10 times more, so I need to multiply this figure here by 10, so that is going to be 208.3, well, 3 recurring, so that will be £208 and 33 pence. Okay, so part C, Dan needs to make a mixture of weed killer and mortar to clean Mr. Patel's patio, and the key thing is we are covering 63.2 square meters. Now we need 20 millilitres of weed killer per metre squared. So for 63.2 metres squared, we are going to need 20 millilitres multiplied by 63.2, and that comes to a total of 1,264 millilitres of weed killer WK. Okay, now we know that the ratio of weed killer to water is the ratio of 1 to 10, so that means we need 10 times more water than we do weed killer. So the amount of water we need is 1264 multiplied by 10, which is 12640 millilitres of water. So the total volume of stuff we need, water plus weed killer, is 12640 plus 1264, and that comes to a total of 4, 10, carry the 1, 6, 7, 8, 9, 3, 1. So millilitres of liquid. Now the capacity of the container is in litres, and there are 1,000 millilitres in a litre, so how many litres is that? That's 13904 divided by 1,000. So that's 13.904 litres. So if the capacity is 5 litres, then 5 litres, if I fill it up twice, that's 10 litres. So I'll need to fill it up a third time. I don't need to fill it right to the top, but it will need to be filled 3 times. So the answer is, how many times does Dan need to fill the spray tank to cover the whole patio? Depends what you understand by fill. For me, filling in this case means putting some liquid in it. If your interpretation is completely fill it, as into the top, then the answer would be 2. But here, in my opinion, I think the more sensible answer is 3. Okay, 2D. So what we need to do here is work out an estimate for the mean time that he takes per cleaning job. So he's done 25 jobs that take between 30 and 60 minutes. Now those 25 jobs might have taken 30 minutes in a second, or they might have all taken exactly 60 minutes. So what can we do? Well, the best is to take the midpoint and assume that all of these jobs took 45 minutes. So here's a column here for the midpoints of these ranges. 60 to 90, the midpoint is 75. If you're struggling to work out the midpoint, by the way, just add the two values together and divide by 2. So the midpoint of 90 and 120 is 105, and the midpoint of 120 and 150 is 135. So what we're doing is we're assuming that 25 jobs took 45 minutes each, so the total time of these jobs is 25 times 45, which is 1125. So here it's the frequency times the midpoint. So often this column here is just called is the frequency column. So we're multiplying these two columns together, and 36 times 75 is 2700, 4725, and 21 times 135 is 2835. So the mean time is going to be the estimated total time taken. Sorry, this is the estimated mean rather. It's going to be the estimated total time taken, which is the sum of these values here. And if I add these together, that comes to 11385, and it's going to be this estimated total time divided by the number of jobs. So 11385 divided by 127 jobs, that is an estimated mean of 89.645666929, and that is minutes per patio or per job. We probably don't need quite so many decimal places, but okay, let's leave it as it is for now. So how many hours is he planning to work next year? Well, 8:30 to 3:30, 8:30, 9:30, 10:30, 11:30, 12:30, 1:30, 2:30, 3:30. That is 7 hours. So it's 7 hours for 5 days times 26 weeks. So what is the total number of hours? That is, so total hours is 7 hours a day times 5 days a week times 26 weeks for the spring and the summer, and that is 910 hours. Now, since I've got this in minutes, I probably want to turn this into minutes as well. 910 hours equals 910 times 60, which is 54,600 minutes. So if we're assuming that it takes him this amount of time for one patio, and he has this time available, so how many patios can he do? Well, that's going to be 54,600 divided by 89.645666929, and that gives us a value that's slightly above 609. So I think 609 patios would be a sensible answer there. Okay, so the questions so far have been pretty challenging. This E is probably the easiest of the lot, so it's nice to have a bit of respite here. Dan's accounts are checked by the tax office. They pick one of last year's jobs, so we know that there are 82. So out of the 82, how many took more than 90 minutes? Well, these ones took more than 90, and so did these. 30 plus 16 is 46. So that is 46 out of 82. Both of these numbers are even, so we can simplify the fraction by dividing top and bottom by 2. Top divided by 2 is 23, and the bottom divided by 2 is 41. Both of these numbers are prime numbers, so the fraction cannot be simplified anymore, so that is our final answer. 23 over 41. Okay, so question number 3. There are 51 million adults in the UK. 20.5 million do not do any regular exercise. So that means that 20.5 million out of a total of 51 million, do no exercise. Now this fraction could be simplified by just getting rid of the word million top and bottom. The only problem now is we've got a decimal in a fraction. We've got 0.5, which is a half. So I know that if I multiply the top and the bottom by 2, I'll get rid of that decimal. 20.5 times by 2 is 41. 51 times 2 is 102. 41 is a prime number, so that is the fraction in its simplest form, 41 over 102. Remember also that the line of a fraction means divide, so you could just type into your calculator 20.5 divided by 51, and if you've got a calculator like mine that automatically will give you a fractional answer first, you'll see your calculator will give you the answer at 41 over 102. 3b, we just need to turn 0.06 into a fraction and a percentage. Well, we have two decimal places. When you have two decimal places, we are talking about 1/100th, so that is 6/100ths. But the fraction can be simplified. We have two even numbers, so if I divide the top by 2 I get 3 and the bottom by 2 I get 50, so as a fraction that is 3/50ths. Now to turn a decimal into a percentage, you multiply by 100, and 0.06 times by 100 is 6, so that is 6%. Okay, 3c. So I've struggled a lot with this question. This is probably the 8th attempt at recording this video as a result of this particular question. The problem all relates to the graph and the fact that the range of answers that they are prepared to accept doesn't seem to be particularly flexible. Anyway, the first thing we need to do is work out her maximum heart rate. Now remember that 0.007a squared means 0.007 times a squared. So the calculation is 191.5, take away 0.007 times a, which is her age, 25 squared, and that comes to 187.125 beats per minute. So this is Jackie's maximum heart rate. Okay, now we know that we've been told she's working at a 72% effort. So what is 72% of 187.125? The calculation is 0.72 times 187.125, and that is 134.73, which is approximately 135. Now this figure here, this is the percentage multiplier for 72%. It's the decimal equivalent of 72%. It's 72 divided by 100. So if you are not sure where that came from, hopefully that helps. Okay, so 135 beats per minute. Now if we take a look at the graph, we've got beats per minute, but along the bottom we've got power, and we don't want power, we want kilocalories. However, if we get the power from the beats per minute, then we can turn the power into kilocalories per hour. Now, 135 beats per minute, this point here is 130, so 135 is in between. Now the first thing we need to do is draw a line of best fit. Now, I often say that if I ask 10 students to do a line of best fit, they might come up with 10 slightly different lines, and they are all perfectly acceptable. So it's not a one size fits all, but for the purposes of this question, it does seem that if you do the line of best fit slightly not the way they want it, then you'll end up with an answer that doesn't fall within their range, and that's where I've been falling foul here. Okay, so remember the line of best fit goes through the middle of the data, trying to keep the same number of data points above and below the line. So for example, this would be a terrible line of best fit because we've got like one above and all the rest below, and this is also not steep enough because there's too many above and not enough below. Okay, so this is going to be, I think the line of best fit will be something like this, in my opinion. Okay, so what we need to do here, usually you get the mark, as long as usually if you can draw a line of best fit that looks acceptable and prove that you know how to use a line of best fit, then you'll be absolutely fine. But with this question, it doesn't quite work out like that. So I'm going to go up to 135 beats per minute, which is halfway between 130 and 140. And you should use a pencil and a ruler to do this. And I'm going along here and I'm hitting the graph at this point here, which as far as I'm concerned takes me down to 160 watts. Okay, so 160 watts. So we know that 100 watts uses 350 kilocalories per hour. So I'm assuming the way it works is that 200 watts would use double that. I suspect in reality that is not the case, but that's the best we can go with here. So if 100 watts uses this amount, what does 160 watts use? So what I need to do is first of all work out what 1 watt uses. If 100 is 350, then 1 is going to be 100 times less than this, so 3.5 kilocalories per hour. So if 1 watt uses 3.5, then 160 is going to use 160 times 3.5, and 160 times 3.5 is 560 kilocalories per hour. Okay, so that is the final answer, which just about creeps into the range that they were expecting, so 560. Okay, part D. So what we need to do first of all is work out the mean for week 1. So that's going to be 26.3 plus 22 plus 28.1 plus 24.9 plus 18.4 plus 21.7 plus 20.3, and that comes to a total of 161.7, and there are 7 values in total. 161.7 divided by 7 is 23.1, and that's minutes. Okay, so now let's work out the mean for week 12. So we're going to do exactly the same thing. Just add up all of these values again. So 23.9 plus 20.2 plus 25.7, and so on and so forth. And we get a total of 143.3, which is going to be divided by 7 to give us a mean of 20.9 minutes. Okay, so has the group achieved its target? Well, the target was to reduce the mean for week 1 by 11%. So if they're taking off 11%, that means that the new value needs to be at the most 89% of what it was before. So let's work out what 89% of 23.1 minutes is. So what is 89% of 23.1 minutes? So the calculation is 0.89 times 23.1, and that comes to 20.559. So this is the time they were aiming for, but they've got a bigger time, which means that they were slower. So has the group achieved its target? The answer there is no. Okay, part E. So starting at A all the way around to, actually this is kind of irrelevant. All we know is that what we've been told is 1 mile is 1.6 kilometers. So therefore 12.5 miles, that's going to be 1.6 multiplied by 12.5, and that comes to 20. So that is 20 kilometers. So we've been told the total route is 23. So what fraction has she cycled when she reaches B? Well, that is 20 out of a possible 23. And that is the answer, 20 over 23. 23 is a prime number, so we can't simplify that fraction at all. Okay, so what we're going to do first of all is, using this bit of information here, work out how much a biscuit weighs. So 135 grams divided by 25 is 5.4 grams per biscuit. Now the new pack was 108 grams, so how many 5.4s are in 108? In other words, what is 108 divided by 5.4? And the answer is 20 biscuits. Now that's not the answer, it says how many fewer biscuits. So there were 25 originally, so 25 take away 20 is 5. So there were 5 fewer biscuits. Nice and easy, that one. Part B. So when we're eating pizza, it's the volume of pizza that makes well, I suppose the greater the volume, the more pizza. It's not about the surface area, it's also about its depth as well. Okay, so what we need to do is work out the volume of each pizza. Now a pizza is a circle. Well, it's basically a cylinder. It's a very sort of almost a flat cylinder. Now so it's a three-dimensional shape. The volume of any three-dimensional shape, provided it has a constant cross-section, which let's say a pizza does, even though it probably doesn't in reality, it's going to be the area of its face multiplied by its depth, and the area of its face is a circle, so it's pi r squared multiplied by its depth or its height. So pi r squared times depth. We've been told that pi is 3.14 here, so let's work it out for the large. So 3.14 times, okay, the diameter is 38, so the radius is going to be half of that, so 19 times by 19 times by 2, and that comes to 2267.08 cubic centimetres. Let's go for the small. So that's 3.14 times half of 19, which is 9.5, times 9.5 times by 1.5, and that is, no it's not, it's 425.0775 cubic centimetres. So we want to know, is the large size at least 5 times the small size? Well, let's do the small times by 5, which is 425.0775 times by 5, and that is 2125.35 cubic centimetres. So that is still less than the large, so therefore yes, Beth is correct. The large piece is more than 5 times bigger than the small one, so yes, Beth is correct. Okay, part C. So we've got the pizza box here, so it's made up of 2 squares, 40 by 40, and lots of green rectangles. They're the sides and the flaps, and they are reducing the dimension to 38 by 2. Okay, so what I'm going to work out here is the surface area of the box as it stands. So we've got a 40 by 40 square and another 40 by 40 square. So that's 40 times 40 doubled. 40 times 40 times by 2, that's 3,200. And these green rectangles, they are 40 by 2.5. So 40 times by 2.5, and we have 1, 2, 3, 4, 5, 6, 7, 8. There are 9 of them. And 40 times 2.5 times 9 is 900, so the total surface area is 4,100. Okay, so we're changing these to 38 and 38, and the flaps are reduced to 2. So what we've got here, the new surface area, is going to be 38 times by 38 times by 2, and a 38 times by 2 times by 9. Okay, so 38 times 38 times 2 is 2888. 38 times 2 times 9 is 684. Add those together, we get 3572. So the pizza box has reduced from 4,100 square centimetres, and it's gone down to 3,572 square centimetres, and we want the percentage reduction. Okay, so what is the percentage decrease? Now the formula for a percentage change, whether it's a reduction or an increase, is the difference divided by the original amount multiplied by 100. So 4,100, take away 3,572, that is 528. So what is 528 as a percentage of what it was originally, which is 4,100, times by 100, and that comes to 12.878. So maybe just round it to 1 decimal place or the nearest whole number. So I might just call that 12.9%. Part D, we are interested in the plan view, so that is the view from above. So if we're looking at this triangular prism from above, then all we will see is a rectangle. In fact, let me just draw it to the side here. So there we go, that is what we will see, and this edge here we will see as a straight line, and we will also see all these lines here, which will be going horizontally. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, just about squeeze them in, and we need to label this. So this is 6 centimetres and this is 10 centimetres, and that is the job done for that question. Okay, and on to the final question here. So here we want to calculate the size of the angle labelled A. Well, it's a triangle. Angles in a triangle add up to 180. So far we've got 50 plus 50, which is 100. So 180 degrees, take away the 100 degrees is 80. So A will be 80 degrees. And this is the end of the assessment.